Hey guys, welcome back. Today is day 7, and today we're going to learn about translating expressions and equations, which would be word problems. Okay, so we can start out by saying that an equation is actually a mathematical sentence that represents two expressions that are equal to each other. Okay. Remember, when you see the word quantity, you must use parentheses. Okay, so think about the word. Okay, so we're going to use parentheses when we see the word quantity. Okay, that's from a few blocks ago. We talked about that when we translated some expressions. But what's new today is when defining a variable, we're going to create what's called a let statement. Okay, you're going to see me say let something x equal whatever. Okay, so that's our let statement. So, for example, we have translate the following and solve. 2 times the quantity 6 less than a number is 24. What is that number? We're going to start with the let statement because we're going to define x to be the number that we're looking for. So let's let x be the number. Okay, so if we wrote 2 times the quantity, so 2 times quantity would be in the parentheses of 6 less than. Now remember, the word than means the 6 comes after, so x minus 6. And then an is would be an equal to 24. Okay, so we just wrote an equation, which is really the mathematical sentence that represents this expression equaling this expression. Okay, now we solve it. We go back to using DC-MAM. 2x minus 12 equals 24, so we just distributed. Okay, 2 times x, 2 times negative 6. I'm going to add the constant here, 12. All right, and I get 2x is equal to 36. When I divide by 2, my x is going to be equal to 18. So I always go back and I make sure, am I answering the question? What is the number? The number is 18. Okay. So we're just going to go through a series of examples, and hopefully you'll start to see how we pull them apart, and we identify the let statement, and we then get our equation, and then we solve. So Marie bought 12 pieces of fruit, of which there were X apples. Well, there it is already. In this case, they already gave us the let statement. Let X be the apples. Now at this point in algebra, we're only going to have one variable. Okay, so keep that in mind when you're coming up with your let statement. So we have 5 fewer oranges than apples. Okay, so oranges. Okay, we're not going to have a separate variable for oranges because we can write 5 fewer oranges than apples. So if we took apples, which is x, and we said 5 minus that, or minus 5, we would have 5 fewer oranges than apples. So we take the apples minus 5 would be our oranges. And then it says, and 1 pineapple. So pineapple is actually just a constant. Pineapple is equal to 1, okay? But we're looking for how many apples and oranges did Marie buy. Okay, she bought 12 pieces of fruit. That means if we took our apples, we added our oranges are x minus 5, and then the 1 pineapple, we would get 12. So that's actually the hard part, coming up with the equation. Now we are just going to combine our like terms, 2x. Okay, we've got a negative 5 and a positive 1, so minus 4 equals 12. We add our constant. I'm going to go kind of fast through the solving equations piece of it. 2x is 16. We divide by 2, and our x is equal to 8. Well, what does that mean? It means we have 8. Our x is apples, so we have 8 apples. And our oranges would be 8 minus 5 because x is 8, so 8 minus 5 is 3. So we're going to have 3 oranges. So that would be our answer. Okay, moving on to number 2. Cucumbers cost $1 each and tomatoes cost $2 each. Mom buys 6 more tomatoes than cucumbers. Her total bill is $36. Find out how many tomatoes and cucumbers Mom bought. Well, let's start out. Let's see. So we know that Mom buys 6 more tomatoes than cucumbers. So we can write tomatoes relative to cucumbers. So let's start out and let's let C be equal to cucumbers. Okay, we don't always have to have X. Okay, if C is cucumbers, then what would tomatoes be? Keeping in mind that we only want to have one variable, we're going to write an expression. So since Mom buys 6 more, it would be C plus 6. Okay, tomatoes would be C plus 6. Okay, if cucumbers are $1 each, that means we would take $1 times every cucumber she buys. So we would multiply, and I'm going to write it out, 1C. Okay, and tomatoes would be $2 each. Well, tomatoes are represented by C plus 6, so it's $2 each, and we're spending $36. Okay, so now when we distribute, we get C plus 2C plus 12 is equal to 36. Okay, we're going to combine our like terms. 3C plus 12 is equal to 36. Then when I subtract my 12 from both sides, I get 3C is going to be equal to 24. And when I divide by 3, my C is equal to 8. Okay, a lot of times with word problems, I like the variable to begin with what the let statement is. So cucumbers would be C. So I know at the end, it's actually 8 cucumbers. Okay, so it's 8 cucumbers. And then I plug it back in and I say, well, C plus 6. So it would be 8 plus 6, which would be 14. So we would have 14 tomatoes. Okay. All right, let's try another one. Again, at any time, I really want you to pause this video and stop and think about it and understand it as you go through. The purpose of this video is just really to kind of summarize what we did in class. We are going pretty fast. It's not intended that you're going to sit and treat this like an asynchronous lesson and not have attended the class. So it's just, okay. Okay, so for number 3, we have Jack is 25 years younger than his mother. Together, the ages add up to 89. Find each of their ages. Okay, so I'm going to start out and I'm going to let M be the mom. Okay, if M is mom, then we're going to let Jack, okay, is going to be equal to mom minus 25 because he's 25 years younger. But if we took their ages and together they add up to 89, if we took mom and we added Jack, we would get 89. Now we combine our like terms and we get 2M minus 25 equals 89. Okay, but now we add 25 to both sides rather. We get 2M is equal to 114. We're going to divide by 2. And mom is going to be 57, okay? And that's why sometimes I do like, again, having my variable be whatever we're looking for. So M is mom, okay? So in this case, we plug it back in and we figure out that Jack is actually going to be 57 minus 25, which gives us 32. So mom is 57, Jack is 32. And together they add up to 89. All right, so moving forward with number 4. All right, the sum of 3 consecutive integers is 165. Now this is important. Consecutive means one after the other. So if I had the numbers 4, 5, and 6, they would be consecutive. Okay, they're 3 consecutive integers. If I had 31, 32, 33, they would be consecutive. Okay, so in order to determine the sum of 3 consecutive integers, I'm going to start out with my let statement, and I'm going to let f be equal to the first number. Okay, now I know I need the first, the second, and the third. Okay, now if f is my first number, my second number would just be the first plus 1. Okay, and then my third number would actually be my first number plus 2. Okay, so for instance, if I had 4 and I added 1, I would get 5, and added 2, I would get 6. So those are 3 consecutive integers. That's how we can represent it. Now we're taking the sum, that means we're adding them. So if we take the first, we add the second, and we add the third, we're going to get 165. Okay, so remember, this is the first, f is the first, the second is right here, f plus 1, that's the second. I'll go, this is the first, and then this one is the third. Okay, so if we take the 3 of them together, we get 165. So now I just combine like terms, 1, 2, 3 f's, plus 1 plus 2 is 3, and that's 165. I'm going to subtract 3 from both sides, running out of space, so 3f is going to be equal to 162. And then I'm going to divide both sides by, whoops, not by f, but by 3, whoops. Okay, divide both sides by 3, and our f is actually going to be equal to 54. All right, but be careful. All right, that's our first number. What's the question asking for? The largest number. The largest number is going to be 54 plus 2, which is 56. So 56, we would write the largest number is 56. Okay, is 56. All right. Okay, number 5. The second of two numbers is 4 times the first. Their sum is 45. So let's let f be the first number. Okay. The second number is 4 times the first, so we can write an expression that represents the second number. That would just be 4f. So if we take their sum, the sum is addition. So if we take the first, we add the second, we're going to get 45 because their sum is 45. Now this becomes pretty easy to solve. 5f is 45. We divide by 5, and f is equal to 9. Okay, so it says to find the numbers. So the first number is 9, and the second number would be 4 times 9, which would be 36. So the two numbers would be 9 and 36. Okay, and then our last example we have, 7 times the sum of a number and 4 is the same as 8 decreased by 3 times the number. Find the number. Okay, sounds like quite a puzzle. So let's let x be the number. All right, 7 times the sum of a number and 4. Well, if I take the sum of a number and 4, that would be x plus 4. That's the sum. But if I want to multiply it by 7, I've got to put it in parentheses. Is the same is another way of saying it's equal to. 8 decreased by 3 times the number. 8 decreased is 8 minus. 3 times the number is 3x. So that's the hard part, is coming up with the equation. Now, distributing and combining like terms and moving the variable should start to get pretty easy. Okay, so I'm going to add 3x to both sides. We'll get 10x plus 28 is equal to 8. And when I subtract 28 from both sides, 10x is equal to negative 20. Okay, so then I divide. I'm going to do it up here. Let's do a little line here. So 10x is equal to negative 20. When I divide by 10, my x is negative 2. All right, and these will work the same. Just plug it back in and make sure it works into your check step. Okay, so I hope this helped. Again, I want you to pause the video, go back, and make sure you follow along.